Bismillahirrahmanirrahim. So now let's discuss the idea of the heap sort. So how does this heap sort algorithm sorts the data elements? So I will explain the logic of this heap sort first with one example, and then we will write the algorithm using that logic, and then we will analyze the time complexity and the space complexity of this heap sort algorithm. So how does this heap sort actually works? What is the logic of the heap sort? So in order to in order to sort any data set, a given data set using the heap sort, the necessary condition is, first of all, say for example in this example, um, let's understand with this example. So first of all, if this data set is given in an array, what we need to do, first of all, you need to build a max heap, right? If you want to sort the data elements using the heap sort, first of all, what you need to do is you need to build a max heap using the build max heap algorithm, right? If it is not a heap already, right? So I have already built a max heap of the given data elements, and this is present here. So you can see this is a build max heap. Then what I need to do, now understand the logic. It says this is the size of the array, right? And the size of the array is also the size of the heap, right? Heap size, length of the data is also the heap size. And as we discussed in the previous video, within this size of the array we can have the smaller heap size. So we will utilize that concept as well in this video. So what's the logic? The logic is build a max heap and then swap the root node with the last element and decrement the heap size, right? So what does it mean? First of all, the first step what you need to do is just swap the root node with the last node, right? And then swap it, then decrease the size of the heap. What does it mean? It means move 16 here, right? And move 1 here, swap them, right? And decrease the size of the heap. This is not the part of the heap now, right? So let's update the array as well. So 1 will come here, 16 will go here, but then this is the array, but this is not the 16 is not part of the heap now. The heap size is now from 1 to 9. Is that clear? So the first step, we swap the root with the last element, with the last node, and decrease the size of the heap by 1. Now what? Now this is not a heap anymore, right? You can see the properties violated. This is not a max heap. So the parent is smaller than its children. So now what we need to do, we need to build the heap again, right? So the idea is very simple. Build a max heap, exchange the root node with the last element, decrease the size of the heap by 1, again build the max heap, and do it for every node. So if I build the max heap, so using the build max heap algorithm that we discussed in the previous video, so what will happen in this way? What will happen? So the 14 is the largest, so 14 will go up, 1 will come down, right? I'm going to do directly in order to save time. So 14 will go up, right? Now the max heapify will be called on the here because this was the largest, and here 8 is the largest, so 8 will go up, 1 will come down, 1 will come here, and it will go here, and max heapify will be called here, right? And here 4 is the largest, so 1 will be swapped with 4, so 4 will go up and 1 will come down, right? Now this is the max heap. We use the build max heap algorithm in order to build a max heap, right? And then again do the same. What? Exchange the root node with the last node, right? And decrease the size. So what I'm going to do, I'm going to move 14 here, 1 here, so exchange it, right? So what will happen? So 1 will again come to here, this place, and 14 will come here, and the heap size will be decreased by 1 again. So even the size of the array is of 10 elements, but the heap size is from 1 to 8 now. Clear? So 1 is again there, so this is not part of the heap anymore, right? index 9. Clear? So what happens now? Again, this is not the heap, this is violating the heap property. Use the build max heap algorithm once again in order to build it. So what will happen? Again this will be compared. So which one is the largest among all these three, right? Remember the heapify procedure. So this 10 is larger, so 10 will go up and 1 will come down, right? And max heapify will be called here. Here which one is the largest? 9 is largest, so 9 will go up and 1 will come down, right? That's it. Then what? So let's update the array. So at first position it is 10 and the right of 10, that is 3, will be 9, right? And then on the left of 9, that is 6, that will become 1, right? Clear? So this is the situation now. And then what? Again repeat the procedure. Decrease the size of the heap by 1. Decrease, okay, sorry. First exchange the root node with the last element, that is last index is 8, last index of the heap is 8. So 10 will come here and 2 will go in the root. Clear? Clear? So here 2 will come here at position number 1 in the index, and 10 will come here at the location number 8, and decrease the heap size by 1. If we decrease the heap size by 1, so it means the heap is now from 1 to 7th index. Clear? Fine. Now is easy again. Build the max heap again. So if we build the max heap, we can see out of these three which one is largest? 9 is largest. So 9 has to go up and 2 will come down, right? Out of these three, call the max heapify here. Out of these three, which one is the largest? 3 is the largest, so 3 has to go up and 2 has to come down. Clear? Now let's update it. So 9 is at position 1, and on the right child 3 is at position 3. 3 is at position 3, and on the right of 3 is 2. Right of 3 is 7. 7 is 2. Okay, fine. And then what next? Repeat the procedure. What is that? Exchange the root node with the last node. Last node is 7. Size of the heap is from 1 to 7 now. So 9 and 2 will be swapped. So 9 will come at 2 will come at root. 9 will go at the last position, right? Exchange it in the array as well. So 2 will become at the first position and 9 will go at the 7th location. And what next? Next is decrease the heap size. So this is not part of the heap. 9 is not part of the heap now. 7th index is not part of the heap. So the heap is from now 1 to 6. Clear? So this is index number 9. This is index number 8. Then what? Again, this is violating the property of the heap. So let's fix it using the max heapify. So which one is the largest among these three? So right, 8 is largest, is has to go up, 2 has to come on the left, right? Again, call the max heapify here in order to fix it. So 7 will go up and 2 will come down. Clear? So update the array. Obviously array will be updated because this all is happening in the array. So at the first position 8 will come here, and on left of 8, that is position number 2, 7 will go, right? And on the third position, left of 7, that is position number 4, that is 4, right? And fifth location is 2, sixth location is 1, and third location is 3. That's fine. Clear? And then what next? Again we have to repeat the same procedure. What is that? Exchange the root node with the last element. Last element is now 6, so 1 has to go up, right? 8 has to come at the last position, and then decrease the size of the heap by 1. So this is no more part of the heap now. So let's update the array. So 1 has to come at the first position, 8 has to come at the 6th position, and the heap size is decreased by 1, right? Clear? So what next? The heap property is violated. Call the max heap, build max heap in order to fix it at the root node. So which one is the largest? 7 is the largest. So 7 has to go up, 1 has to come down, right? And call the max heapify here. So which one is the largest? 4 is the largest. So 4 has to go up and 1 has to come down. 4 is going up and 1 is coming down here. Right now this is the max heap. So update the let's update the array as well, right? So since this all operation happens within the array, so nothing is changed, nothing is implemented like a tree or the pointers. So everything is happening in the tree, right? Okay, so that's fine. Now what next? Now again exchange the root node with the last element. So last element here is the last node is 5. So 2 has to go up and 7 has to come down, right? And this is not part of the heap now. So 2 has to come at this position number 1. 7 has to go to the position number 5 and heap size is decreased by 1. That is not part of the heap now. Clear? So now what? So this is not the max heap. So call the build max heap algorithm in order to make this max heap. So out of these three, obviously we are going to start from the index number 1. For out of these three, which one is the largest? 4 is the largest. So 4 has to go up, right? And 2 has to come here. Clear? And then call the max heapify here. This is already a max heap, so everything is fine. So let's update the array again. So this is 4 at the first index, at the second index is 2, third index is 3, and fourth index is 1. Fine. What next? Let's repeat it again. What? Exchange the root node with the last element. Last element in the heap is now 4. So 4 has to come down and 1 has to go up, right? And 1 has to go up and 4 has to come here. And this 4 is now not part of the heap. Decrease the heap size by 1. So this heap size is decreased by 1, right? So this is not part of the heap. So what next? Again, this is not a heap, so let's call the build max heap algorithm in order to fix this. So which one is the largest? 3. So 3 has to go up and 1 has to come down, right? So and then we have to call the build max heapify algorithm here. So this is since this is a leaf node, this is already a max heap. Again, what next? Okay, so we need to update this array as well. 3 and this is 1. Okay, so now what? Now again we have to exchange the root node with the last node, that is the leaf node, right? So 1 has to go up and 3 has to come down, and we need to reduce the size of the heap by 1. So 1 is at first position and 3 is at third position, and the heap size is decreased, right? Fine. So again, let's call the build max heap algorithm here. So build max heap algorithm says whatever is the largest, it has to go up. So 2 is going up, 1 is going down, right? So that's the max heap now. Again, what we need to do? Again, exchange the root node with the last element. So the last element here is 2. So this will be exchanged. So 2 will come here, 1 is going here, right? And what we need to do, and this is not part of the heap now, decrease the heap size. So 1 is at the first place, 2 is at the second place, and 2 is not part of the heap now, right? Clear? That's it. And then what we have to call it one more time, or we don't need to call it, as 1 is already a leaf node now and it's a max heap now. If you see, you observe this array now, this is a sorted array. That's the idea of the heap sort, that build a max heap, exchange the root node with the last element, right, and decrease the heap size, and do it for every node except the root node, right? So this is the idea of the heap sort, that how heap sort is working. Now let's write the algorithm for the heap sort. So how we can write the algorithm of the heap sort? So heap sort for any for any array, for any heap A, how we can write the heaps, how we can implement the algorithm of the heap sort. First of all, what is the first step that we need to follow? First of all, call the build max heap algo. If it is not a max heap, first of all convert it into the build max heap, right? Build max heap of this array. So first of all build a max heap, then what we need to do, we need to exchange the values and decrease the heap size for every node. So better to put it in a loop. So let me just start from a loop for I that starts with the length of the array, right? Heap size length, a dot length, right, down to, and come back, start from the last, obviously down to 2. Why 2? Because index number 1 is already a leaf node, so no need to fix it, that we not need to exchange it with anything, and not need to decrease the size of the heap. And then what we need to do, we are going to exchange array of 1 with what? With array of I, right? So if like in this example, if the size of the array is 10, so it will start from the 10 to 2, right? And it will exchange 10th position at first iteration. It will start from 10 down to 2, the 10th location with the first location. And then what? Then we need to decrease the heap size, isn't it? So what I am going to say is a dot heap size need to be updated with a dot heap size minus 1, isn't it? Right? And then what we need to do, we need to, since we exchanged it with the first location, we need to call the max heapify. We need to heapify it in order to build a max heapify on a comma 1. For the first index, call the max heapify algorithm in order to build the max heap again. That's it. So this is a simple algorithm for building a for sorting the data elements using the heap sort algorithm, right? Heap sort. So what's the time complexity of this heap sort? So we already know that what is the time complexity of just 1 minute, let me change the color. So what is the time complexity of this build max heap? We already know that this is nothing but order of n, isn't it? Right? And what is the time complexity of this max heapify? That is nothing, order of log n, right? And this order of log n is being executed how many times? Right? This order of log n, this heapify is being executed for every node, right? For n times. So this is in n. So that is what? N plus n times log n, right? N plus order n plus n into log n. Okay, let me just write it one. N for this build max heap plus n for this loop, and inside the loop we are having max heapify, that is log n. So if you compute it in terms of big O, that is nothing but order of n log n, right? So the big heap sort algorithm executes in order of n log n time. Is that clear? Right? Why it is n? Because this n is the separate, so this is, so we always take the largest term when we are talking about the big O, right? So that's why this is n log n, right? So this heap, we use this heap data structure in order to build the priority queues, right? So we can using the max heap, we can implement the priority queues with to extract max value that is at the root in order of 1 time. So in the coming video, I will be talking about the priority queues and how we can implement priority queues with the help of heaps. Thank you.